Thank you. Here's JJ.
You hear me? Yeah. Okay, so I'm going to talk about a pattern I came up with in January. It's been about a year in working. I first published about it last June, about a year ago, and in January I wrote an article that kind of went viral, at least from the kind of article I write. And I don't know if any of you have read that article or heard about the SAM pattern. Yes? No? Okay. So hopefully I'm going to be able to give a little bit more details. And just to set the stage of the discussion, I think everyone knows that modern graphical user interfaces have become just a node in a dynamic distributed system. It's not what it used to be. I don't think people want to build front ends that look anything different than what you see everywhere. And that would involve friends and players, your watch, IoT sensors, interacting with the GUI just as much as the user would. The problem is that the bread and butter of front-end architecture has been, even in callbacks, for as far as most people would remember, at least I would remember. And if you look at this code where you're trying to draw a rectangle as you drag the mouse on a screen, that code has not changed in a while. And if you dissect it, some really smart people have, you realize that it's really hard to compose that code. It's not kind of component-oriented. It doesn't have much encapsulation. It's most often relying on global variables. It's relying on subscription, therefore you have to subscribe and unsubscribe to events, and that's a little bit iffy. Separation of concern is really not that great because you start, drawing some elements of the user interface within the event handler. You have to deal with subtle bugs due to the data consistency. As you start updating the model and the global variables, things again get a little bit iffy as lots of events are propagating through the code. And of course, it becomes often a maintenance nightmare when you have thousands of lines of code that just look like that. And in all fairness, that code probably doesn't look different as the code that was built to implement the first version of application on Windows 3.1. I found this interesting article. There is a major airport in Paris, the second major airport, which still runs a Windows 3.1 app for the takeoff and landing of airplanes. So if you ever go to France, just don't go to that airport, because I certainly wouldn't. And that it took down the airport. I mean, they struggled to find parts for the computer to run Windows 3.1, and it took down the airport last year. So anyway, so I'd like to kind of create a picture, a mental picture of at least how I see front-end architecture. I'm more like a back-end guy. I've done a lot of SOA stuff for the last 15 years. And I've recently kind of, through APIs, started to do more front-end stuff. And I don't know if any of you have traveled to Thailand, but throughout Thailand, you would see telephone wires that look like that. I'm not joking. It's absolutely everywhere. And most of them look exactly like that. This is not an extreme picture. Even in the most modern part of Bangkok, you would see those wires. And that's really how I see front-end architecture. So I set out, I did my little investigation and tried to understand the extent of that, telephone network. And I kind of found the back-end API, those cables hang out of just about anywhere. I found the front end. There's, I don't know, maybe almost a terminal per customer in some business. I did find the devs and the architect kind of working on those wires. I found Redux. This guy is really smart. He said, hell with that. I'll just contain here in that little box. I also found Angular. You have to build this big bridge just to lay out a few wires. Just as of last week, this made the news in Bangkok. People complained about this really modern pedestrian bridge being built with a power pole in it, and you can notice the telephone wires going through it. and do you know why? This is an instance of Scrum. It's because the construction had to be started, the sprint had to go on, otherwise the builder would be fine. So I also found instances of code reuse. Somebody really smart, I don't know if it was a pivot, a new business model, but they decided to hang a billboard, and they use, those really interesting telephone wires to make sure that the billboard was stretched out properly. And reuse comes with the problem of now let's try to share that piece of infrastructure. I cannot imagine how that's going to look like. I also found an Amazon outage. You would think an earthquake had done that. Not really. A single truck took down 47 poles at once and killed one person. It's actually amazing that only one person got killed because it took. So I apologize, maybe it's just too much of a picture. I didn't mean to be dramatic. But this is what I see when I think about front-end architecture. Again, I'm a back-end guy, so maybe the front-end people feel offended. Recently, Sam Stephenson, I don't know him, but he seems to be popular. He came up with this picture. He said, well, life was simple in 2004, and now that we have all those fancy graphical user interfaces, people done a lot of research and came up with very interesting stuff, and this is what we get in 2016. So really, where we are today is the industry is going full speed into what's called functional reactive programming. You cannot read a blog or open an article that's not talking about FRP. And FRP is, if there's a lot of definition, I feel that this one is probably the one most people would have in mind. And it's about building programs in a declarative way by defining event streams, how they link together, and what happens if a new stream value arises over time. To be honest, I don't see any difference with that picture. There's streams that you don't see in that picture, but I don't see a lot of differences. However, FRP is also trying to contain the way you mutate the application state. And I have a bit more issue with that, and that's why I came up with the SAM pattern, because again, I'm not necessarily a computer scientist. I'm probably playing way out of my league here, but I feel a little bit offended when I read, this kind of properties of FRP where you actually don't need application state. Well, in reality, you just bury application state in such a way that it becomes really hard to reason about. And then a lot of people around FRP are reinventing the wheel. For instance, this guy at Facebook, he just came up with the definition of an action. An action is about taking some state, doing something, and getting another state. And not quite. Not quite. I mean, we're in Portland. I don't know if you know the Ira Keller fountain. Anyone? Yeah. I think it's one of the most beautiful fountain I know. If you've not seen it, I would recommend you just go, spend some time this evening or whenever. It's truly beautiful. And you should ask yourself if the action of, adding water to the fountain decides how much water there is in the pool of that fountain. And the answer is no. It's the fountain which decides the level of water it contains. It's not the action. So you cannot make up semantics. You have to be very careful in the way you think about your programming model. So I'd like to spend the next 5 minutes or so talking about the programming models of kind of the leading framework. And you look at Angular, And it's reactive. There's no question about it. You change some pieces of data in a component, and it's designed to somehow reflect that in the UI. It doesn't always happen. You have to kick it a bit sometime, but in essence, that's what it is. It's not very functional, so you wouldn't expect to do much FRP with it. There's a lot of observables everywhere, but it's a bit iffy in my opinion. Something that starts to be not only reactive but also functional is MobX. So it's kind of a new framework. It's built by Mendix, and it's very, very reactive. They really got that part done. It's like you have a piece of data and you change anything, and boom, your UI is tied to it, and it reflects all the changes instantly. In my opinion, it's a bit too instant, but I'm a bit picky in terms of semantics. They recently added action, but in reality, those actions are, again, not actions. They're more like mutations. And the basic assumption behind MobX is that there's a cloud of business logic that you would be building. MobX itself is not a framework that would encompass the whole front-end architecture. So you have to be careful again. When you apply a framework, you use a framework, what it really does for you and where your business logic would fit. So if we continue the journey, you look at React and Redux. It's very reactive by definition. I think they're still searching the programming model that they want to land on. The original one was horrific. Again, they call an action something that's more like an intent. I wouldn't call that an action. You have to use a bunch of stuff other than just React or Redux. You have to use thunks and sagas and lots of other stuff that start popping up, GraphQL, Relay, and whatnot. So, but it's truly functional. The reducer is functional. The front-end part is reactive, so we start to be in the realm of FRP. The framework that starts to be fully funded on FRP is Elm. So it's not only a framework, but it's a whole language. I'll keep the language separate because I don't necessarily like people who create a new language just to solve this kind of problem, but that's irrelevant. And what you see here is they have an update section that's purely functional, but then when you need to deal with side effects, that's where the problem starts because, well, in essence, you need to mutate data. You can't just ignore the fact that data has to change. That's the fundamental purpose of just about any software we write. So they came up with kind of the effects as data model. So you start creating a task that issues a bunch of commands that will start, mutating back the application state. And that's the part I don't necessarily like very much. I know a lot of people love it because they feel it's purely functional. But in reality, there is nothing purely functional. You have to mutate state somewhere, and you have to decide the best way to do it. The last framework is Cycle.js. So this one is a bit of an odd one. It was built by a guy who looked at React and felt it was not that good. He built his own framework. But then he ended up rewriting Cycle.js pretty much every other month. And his community, even though it was very exciting that he was using streams and functional programming, and it was very reactive. It was kind of the purest FRP model you could find. But it's kind of annoying. Every other month, the entire API changes. So this framework is not yet in production. There's a lot of interest. I personally find it a little bit confusing. The application state is completely buried in a stream, and I just find it really hard to reason about. The last point on FRP is that I wouldn't get too excited about it because it doesn't work across network boundaries, period. And the reason is because you need a unit of work when you mutate state, and if you can get away on a single node with FRP, you're not going to get away over a distributed system. That's just not going to work. And people have tried desperately to find a solution, to find a dependency graph that's going to make, create a glitch-free system where anything you send to the server and you're able to kind of synchronize fairly transparently with whatever you want to represent on the client. And nobody has cracked that problem. So all the frameworks that just went over, each time you need to call an API, you're basically on your own. You can stitch it almost anywhere you want, but they're not very prescriptive about where it's going to happen. So I'd like to almost take a 180-degree direction and introduce the SAM pattern. SAM stands for State Action Model. If people have suggested another acronym that I'll go over. But anyway, SAM is trying to answer the same question that everybody is trying to answer, is if the model to view path is clearly functional, this is what React taught the industry. If you're not using functional HTML, or if you're not creating your view as a function of the model, you should really look at that, because this is so powerful that I don't know anyone who would resist the power you get doing so. The problem is what happens the other way around. You get an event from the view or the network, the model needs to update. This is where the industry is struggling today to come up with an answer. And the answer so far has been FRP, and I'm suggesting with the SAM pattern there might be another one. Another one that's focused on mutation. It's not about ignoring mutation or hiding mutation or pretending mutation doesn't exist. It's about making mutation a first-class citizen of your programming model. And it's based on a couple of pieces. I don't know if anyone has heard about the Paxos protocol. No? So it's an interesting protocol. It's a consensus-based protocol to achieve data consistency in distributed system. So now you start seeing the relationship with, kind of modern UI being just a node in a dynamic distributed system. And achieving data consistency in a distributed system is not completely trivial. There is this guy, Leslie Lamport, who's a researcher at Microsoft. He spent his entire career from the 70s building those protocols, and a complete formalism behind it called TLA+. And what the protocol is based is on roles such as proposer, acceptor, and learner. And there's a sequence of messages to achieve data consistency. So let me show you what it looks like, because the protocol itself looks very complicated. But if you translate it on how it works, say in a front-end architecture, it's actually pretty simple. Let's take the simplest model possible. We're going to have a counter, and as events are propagated, we want this counter to increment. In reality, most people would say, well, that's how we mutate state. We just say counter equals counter plus 1 somewhere in response to the event. We just put in a handler, we're done, and then we represent the view. But in reality, this is not how you mutate state. The way you mutate state is you create a proposal, and the proposal is counter plus 1, and then you want the counter to take that value. But we're not done yet to mutate state. The way you do it is you ask the counter, the model, to accept the proposal. And then once the proposal is accepted, once the application state is mutated, then you notify the learners about the changes, and they can propagate the changes to it. And that's it. What you see here is SAM. It's as simple as that. It's just saying when you mutate state, you have to go through those 3 phases. You have proposers who create proposals, you have acceptors who accept the proposals or reject them, and you have learners who do something with the mutated application state. So the way it looks is it's pretty much from the view, you issue actions, nothing new. Except they have very precise semantics that this researcher at Microsoft has defined. You cannot make up the semantics. You cannot just say, oh, an action is just a little JSON structure. You can't, period. In some cases, it reduces to such a thing, but it's not. Then the model is the acceptor. You could have in a distributed system a bunch of acceptors through consensus. They could achieve, eventual consistency if needed. But typically in simple cases, you would have just one acceptor. And then you have learners. And here, this is kind of important because in most front-end architecture, the model is strictly connected to the view. And that's a little bit of an issue. You need a decoupling. If you don't have that, then you start having business logic showing up in the view, and that's the last thing you want. You want the view to be 100% free of business logic. The last concept is that, again, Leslie Lamport built all the theory behind the Paxos protocol and TLA+. And one thing he's been pushing is that there is no well-defined notion of what is a program state. When you say counter equal counter plus one, is that a state? Is that a step? And the reality is not. So the other advantage of SAM, it has a clear definition of what a step is, which you don't have in Elm or any other framework. And SAM is a pattern, so it's not opposing the framework. It's just telling you you could use the framework and you can implement the SAM pattern with any of those frameworks. It works. We created code samples for each one of them, so there's no opposition between the two. But in those frameworks, out of the box, you don't have a notion of step. And what the step would allow you to do is that now you start thinking about what are the actions allowed in a particular step. I can even track what are the allowed proposals, and I'll show you in a second how this can be used. And the step completes when the learners have propagated the changes to the application state. So how do you implement the pattern? It's a unidirectional single state tree data flow that's pretty standard. That's where the industry is going. SAM is no different with that. It's tracking all the events which are mapped to actions, and it hits the single state tree, the model, and then the reactive flow continues until the view is produced. One thing in the middle called NAP, the next action predicate, is often, so in a given state, NAP will compute, is there any automatic action that needs to happen? And that's typically the logic. If you don't have a mediator between the model and the view, you would find, you wouldn't know where to put it, either in the model or in the view, and you would find that it just doesn't fit. So it's very important to have this mediator between the model and the view as you generate the view. Another advantage of SAM is that it's by design isomorphic. So this morning, we had a talk on isomorphic JavaScript. I can show you that the actions, the model, and the state are 100% isomorphic by design. You don't have to do anything additional if you use the SAM pattern. And I've shown that you can move at any time. Even after you design your application entirely, you can decide, I'm going to move some actions back to the server. You can even have third-party actions with OAuth going back into the model if you'd like, and all that is completely covered by the pattern. So you can have the actions and the model, or just the actions, or just the model. You can have any combination of the elements of the pattern moved from the browser to the server. The last point is where, again, all the other framework kind of struggle, and they don't provide almost any real answer to it, is where do you put kind of the backend API calls? And in reality, SAM tells you you can put the API calls that don't have any impact on the model. You can put them within the action, and all the other ones you can put them in. The one that have impact on the application state, you would put them directly in the model. I still have, how many? 5 minutes. Oh, okay. So I just want to show you some little bit of code. So this is a very simple application. It's a CRUD application, so I can add records. Oh, of course, I have to start the server. It would help just a little bit. And so forth. I can, so what I can show you is that I have a time travel functionality. So because it's a single state tree, I can keep track, I can keep snapshot of the single state tree. And here I have it on the server, unlike say Redux, who mostly have it on the client. And I can query all the steps the application went through and what's the current state. And I can, of course, time travel. So if I say I add another record, and I want to time travel back to the second one, what you would see is this is after the second step I had created the test2. So if I want to go back to the last step, it would show me the model as it was. So for debugging, thinking about your app, you can actually look at very easily through an API. You can query what is the application state, and you can see it right there. You can see the actions that were proposed to the model, the kind of values. The last thing I wanted to show is what I call action hangback. So I've simulated a long-running action. So if I change this to a new value, say test 5, and I say save, it's not going to happen immediately. And because I'm state-based, I can cancel this, and it will not happen. However, if you look here, it just happened. It returned, from the action, but the action was prevented to present its data to the model because the step was complete. The cancel action had completed the current step, and therefore there was no other proposal allowed for that step. So you get action cancellation, or if you're Netflix, you could send a number of requests, and the first one that returns will prevent the other one to have effect on your application model. So that's pretty much it. The conclusion is I would be very careful of semantics. The pattern is really focused on mutation. It's functional and reactive. There's a reactive loop. There's as much functional aspect to it as you can, but you cannot ignore mutation. It's a single state tree pattern. It's also focused on what's allowed at any given point. You don't manage subscription. You just declare what's allowed as an action to be triggered or to present to the model. That's very different from having to subscribe and unsubscribe to events or streams. The result, and I can show you, you can look at all the samples, is the view components are 100% decoupled from the application, from the business logic. And of course, it's a functional UI and functional HTML. What's important in the pattern is the wiring is irrelevant or agnostic. You should not focus on wiring. Wiring doesn't bring you anything to your programming model. And from an architecture perspective, it's side effects friendly. It provides this model where you can hang back some actions. You can say, well, this action can no longer propose data to the model because you clearly separated the proposal from the acceptance phase, which is not the case of other frameworks. It's truly isomorphic, and it allows to integrate third-party actions into your overall programming model. Overall, that's a lot of benefits, that you just don't get out of the box when you use React or Angular. So that's it. If you have question, the pattern as a home is sam.js.org. There's a lot of samples that people have produced, I've produced. If you want to create some samples, you're welcome to. All right, that's it.